In this video, I will show you how to use tangent, sine, and cosine to find missing sides and missing angles on a right triangle. And first of all, you simply must have the three definitions memorized. Sine of an angle is the opposite leg over the hypotenuse. The cosine of an angle is the adjacent leg over the hypotenuse. And the tangent of an angle is the opposite leg over the adjacent leg. Of course, the hypotenuse is always across from the 90-degree angle. Opposite and adjacent depends on what angle you're talking about. For example, if this is the angle, then that makes this the adjacent leg because adjacent means right next to. And this is the leg that's right next to this angle. All right, and this is opposite because opposite means across from, and this is the leg that is across from the angle. Memorize this. So, when you do the problem, all of these problems, the first thing you do is label everything as opposite, adjacent, and hypotenuse from the perspective of the angle that's given. So we're looking at this angle right here. Well, first of all, this is the hypotenuse. Always write that down first. This side is opposite, and this side is adjacent. Okay, so we labeled everything. This is opposite because it's across from, adjacent right next to. All right, next, pick the two sides that you're going to be dealing with. So you're definitely going to pick the side that you're given, and then you're going to pick the side that you're looking for. So these are the two sides that I'm going to use as I'm deciding which trig function to do. So this is opposite and hypotenuse. Which trig function is that? Well, that's the sine function. Sine is opposite over hypotenuse. So that's why I know to set up the sine function. So it goes like this. Sine of the angle, so sine of 66, is equal to opposite over hypotenuse, x over 17. When the variable is in the top, this is when you multiply. You multiply by the denominator. That way these 17s cancel each other out. That gets x by itself. And you can just type this in your calculator, 17 sine 66. So we go 17 sine 66. Boom. 15.530. So this is x. All right, we're going to just do the same thing again. We will label everything, starting with the hypotenuse. So this is the hypotenuse. All right, this is the one angle we are given. So we are looking from this perspective. That makes this leg the adjacent leg because it's right next to the angle. And that makes this the opposite leg because it is across from the angle. Now, let's decide which two sides we're going to be using. We're going to use the 16 because that's the side that we're given, and we're going to use the x because that's what we're looking for. So that is opposite and adjacent. Which trig function is that? That's the that's the tangent function. Opposite over adjacent, that's the tangent function. So that's how we know that we are using the tangent function. So we will say tangent of 63 is equal to opposite over adjacent. Okay, when the variable is in the denominator, the easiest thing to do is to swap these. So that is going to give you x is equal to 16 over tangent 63. And then you would just put this in your calculator. So 16 over tangent 63. So that's 8.152. Looking at problem number 9. Again, your first step is to label all the sides, starting with the hypotenuse. So the hypotenuse is here across from the 90 degrees. Now the angle that we should be looking at, we will look at this angle because that's what we're looking for. Okay, now from the perspective of that angle, we are looking for, that makes the 20 adjacent because it's right next to the angle, and that makes the 12 opposite because it's across from the angle. Okay, so we are given both of these sides, so we're going to use both of these. And obviously we have to use the angle because that's what we're looking for. But in terms of the sides, we have opposite and adjacent. So which trig function is that? That's the tangent function, opposite over adjacent. So that tells us that we're going to be using the tangent function. So that's why we will go tangent of x, all right, that's got the angle has to go here, is equal to opposite over adjacent. Now you could simplify this, but it doesn't matter for what we're about to do. All right, this is the first problem where the angle, the unknown, is inside the trig function. So let's just review the 3 types. On problem number 7, the variable was in the top, we multiplied. On problem number 8, the variable was in the bottom, that's when we swapped them. And now here on problem number 9, the variable is inside the trig function. This is when you do the inverse trig function. So you go like this. X is going to equal the inverse tangent of 12 over 20. All right, that's what you do when the variable is inside the trig function. Okay, and then you can just put this in your calculator. To get at the inverse trig function, you have to hit second tangent and then 12 over 20. So that's 30.964, got to round up. First thing you should do is label all of the sides, starting with the hypotenuse. So this is the hypotenuse. Now we have to decide what angle we're going to look at. We're going to look at this angle since that's what we need to find. That makes this the adjacent leg because it's right next to the angle, and that makes this the opposite leg because it's across from the angle. Okay, so we're going to use these 2 sides because they are both given. Now, that is the hypotenuse and the adjacent leg. Which trig function is that? That's the cosine function, adjacent over hypotenuse. So that's how we know we will do cosine of x is equal to the adjacent leg over the hypotenuse. Again, this is another one where the variable is inside the trig function. Whenever the variable is inside the trig function, that's when you do the inverse trig function. So x will equal the inverse cosine of 36 over 49. And just put that in your calculator. $42.719, got to round up. Aw shucks, find the lengths of x and y. We have a double triangle here, folks. Whenever you have a double triangle, my recommendation to you is split it apart into 2 separate triangles and solve one at a time. Okay, why make your life harder than it has to be? So this is 12, this is 35, and this is x. Ah, that's better. That doesn't look so scary. It's just a regular old triangle. So I'm going to solve that. In the meantime, I might as well set up the other triangle. Okay, and on this triangle, there's my x right there, and I have a y, and I have 67 right there. Okay, so let's start by solving the triangle that has only one variable in it. The other triangle makes me nervous because I only have one number and two variables. That could be impossible. So let's solve the left triangle first. So, as we always do, we'll start by labeling everything. Okay, start with the hypotenuse. So this is the hypotenuse. Okay. Of course, we're looking at this angle right here. All right, it's the only angle that we've got. That makes this the adjacent leg because it's right next to the angle. And that makes this the opposite leg. So now let's highlight the two sides we're going to be using. We're definitely going to be using this side because it's given, and we're going to be using this side because that's what we're looking for. So that is opposite and adjacent. Which trig function is that? That's the tangent function. So that's why to solve this problem we will be doing the tangent function. So we will say tangent of 35 is equal to opposite over adjacent. Okay, when the variable is on the top, that's when you multiply both sides by the denominator. So I'm just going to multiply by 12. That way these will cancel out. And you can just put this in your calculator. That is 8.402. All right, now I need to solve the other triangle. The other triangle has too many variables, but that's okay because we just found x. Okay, we just found this. It turns out that x, all right, so I can take away the x, and instead I can put 8.402 in its place. So the rest of the problem is just like any other problem. We start by labeling the sides, starting with the hypotenuse. So this is the hypotenuse. Obviously we're going to be looking at this angle right here because that's the angle that we're given. That makes this the adjacent leg because it's right next to the 67, and that makes this the opposite leg because it's across from the 67. Now let's decide which two sides we're going to use. So we're going to definitely use this side because it's a number that we have, and we're going to use this side because that's what we're looking for. We're going to use the number we've got and the variable that we're looking for. So that is opposite and hypotenuse. Which trig function is that? That's the sine function. So let's set up the sine function. So we will say sine of 67 is equal to opposite over hypotenuse. So that's going to be 8.402 over y. When the variable is in the denominator, this is when you swap these. So this is going to give you y is equal to 8.402 over sine 67. And then you can just put that in your calculator. All right, it's going off the screen a little bit, but I think you can see what I'm doing. So I'm going to do 8.402 over sine 67. All right, so that's 9.128. Got to round up. 9.128. Okay, so for number 12, we're going to use the same picture to find a number of different things. So first, we need to find the length of side FH. So I'm just going to call that x for a moment. All right, I'll just put the x there. Notice that we aren't given any angles, so that makes me nervous until I realize, wait a minute, maybe I don't need tangent, sine, or cosine. If you have two sides of a triangle given, and you're looking for the third side, well, that's just the Pythagorean theorem, which says leg squared plus leg squared is equal to the hypotenuse squared. Please make sure that the hypotenuse goes in the third position by itself. All right, you might have learned a squared plus b squared equals c squared. Make sure that the c is the hypotenuse. Anyway, this would be x squared plus 64 is equal to, and so that's 324. Subtract 64 from both sides. That gives you x squared is equal to 260. Then you have to take the square root of both sides. So x is equal to the square root of 260. And that turns out to be 16.125. You got to round up. Okay, so that's x. But they asked me to find FH. So really, in the end, I should, instead of putting x, I should put FH. Okay. Now we need to find the measure of angle H. Next, we need to find the measure of angle H. Angle H is right here. So focus your eyes on that guy, people. Now, we can label the triangle starting with the hypotenuse. So this is clearly the hypotenuse across from the 90-degree angle. Since we are finding angle H, that makes the 8 the opposite leg. And this would be the adjacent leg right here because it's right next to H. So we've labeled. Now let's think, which two of these three sides are we going to use? Well, definitely this one because it's got, there's a number there. And we're going to use this one too for the same reason. So that's opposite and hypotenuse. So which trig function is that? I'm not ready. That's the sine function, opposite over hypotenuse. So that tells us that we will be setting up the sine function. So we will say sine of angle H is equal to opposite over hypotenuse, 8 over 18. When the variable is inside the function, this is when you use the inverse trig function. So H will equal the inverse sine of 8 over 18. And my goodness, this is something you can just put in your calculator. All right, it's a little bit in the way. Okay, so we will say inverse sine, so second sine, and then 8 over 18. Boom. 26.388. Got to round up. Degrees. Okay, now it's time to find the measure of angle G. Now, when it comes to the measure of angle G, we have two choices. We could start over. Okay, I could erase all of this and start over. Okay, and so if I want to find the measure of angle G, then now I'm looking at this angle, all right, because that's angle G. So when I do my labeling, of course, this is still the hypotenuse. But if this is angle G, then this is adjacent, because it's right next to angle G. And this is the opposite leg, because it's across from angle G. Okay, again, we decide which two sides we're going to use. We're going to use the same sides as before, because these are the two sides that they're both given. So let's go with that. All right, so one way I could find angle G is set up a trig function. So this is adjacent and hypotenuse. That's the cosine function, adjacent over hypotenuse. So I could say the cosine of angle G is equal to adjacent over hypotenuse. And then angle G should equal the inverse cosine of 8 over 18. Okay, so the measure of angle G will equal, and I can put that in my calculator, inverse cosine of 8 over 18. So that's 63.612. All right, so that's one way you could have done it. All right, now here's the other way you could have done it. If you are very confident about the angle H that you just found in the previous step, all right, we decided that this angle was 26.388 degrees. If you know one angle, one of the acute angles, the other one, you should be able to just do 90 minus the first angle. So the measure of angle G should equal 90 minus 26.388. Okay. Oh, look at that, 63.612. So either way, you're going to get the same answer. Now, the advantage of doing it the first way, even though it's an extra step or two, is that we are not relying on another answer that we already found. The disadvantage of doing it the second way is that first we had to make sure that the measure of angle H was right. If you made a mistake on angle H, then imagine this is a quiz or a test. Well, fine, you got angle H wrong. But if you then use that wrong answer to find angle G, well, now you got two questions wrong. So instead of -5, now you got -10, now you cry. So you have to decide for yourself. I can't choose for you. You have to decide for yourself. Do you feel so confident about your first angle that you're willing to risk using it to find other stuff? All right, if you're just very, very confident, then you can just subtract from 90. However, if you're unsure, if you tend to make a lot of mistakes, then you should probably just do the whole problem over again without using the angle that you already found. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.